नमस्कार बच्चों, मेरा नाम धन्या और हम लोग सीख रहे हैं ग्रेड 11 केमिस्ट्री का फोर्थ लेसन जिसका नाम है केमिकल बॉन्डिंग एंड मॉलिक्यूलर स्ट्रक्चर. In today's video, we will be learning about hydrogen bond, what is a hydrogen bond, the types of hydrogen bonding and its applications. Okay. Now, just asking you a question, why do you think water has high boiling point? Or why do you think some substances are soluble in water? Okay. For example, if I say alcohol is soluble in water. Okay. Now, in the previous videos, we learned about ionic bonding. We learned about covalent bonding. We also learned about electronegativity. Yes. And we learned that ionic and covalent bonds are very strong bonds. Yes. We also learned about van der Waals force, which is a weak force of attraction. And we learned the different types also. Yes. Now, hydrogen bond. Now, the hydrogen bond is also a force of attraction. Hydrogen bonding or hydrogen bond is also a force of attraction, okay, which is stronger than the van der Waals force of attraction. It is stronger than van der Waals force of attraction, okay, but it is weaker than hydrogen bond is stronger than van der Waals force of attraction, but it is weaker than ionic and covalent bonds. Okay, so hydrogen bond is also a force of attraction. It is stronger than van der Waals force, but it is weaker than ionic and covalent bond. Okay. Now, for van der Waals force, the bond energy is less than 8 kilojoules per mole. It is very less. Okay. But for hydrogen bond, it is between 8 to 42 kilojoules per mole. So you can see it is stronger than van der Waals force. And for ionic and covalent, it is above 200 kilojoules per mole. So they are the strongest compared to the hydrogen and van der Waals forces. I hope you are with me till here. Right. Now, starting with hydrogen bonding. So in today's video, we are learning about hydrogen bonding. What is hydrogen bonding? What are its applications? It helps to explain why certain substances are soluble in water. Yes. Okay. Coming to hydrogen bonding. Suppose I have an atom A that is covalently bonded to hydrogen. Okay. So this bond is a covalent bond. Okay. And this atom A is highly electronegative. So En stands for electronegative. We have done the video on electronegativity. Electronegative. So highly electronegative atoms can be fluorine, oxygen, nitrogen. Okay. So all these are highly electronegative atoms. So if they are highly electronegative, that means so A is highly electronegative. So if A is highly electronegative, that means it will pull the electron pair towards each other, giving a slight positive charge to the hydrogen, and A itself becomes negatively charged, slightly negatively charged. Now, so this hydrogen is covalently bonded to atom A. Now, if I have another atom B, which has a lone pair of electrons, this is another necessary condition, okay? Another atom B, which has a lone pair of electron, comes near this hydrogen, there can be an attractive force between this hydrogen and this atom B. And this force of attraction is called hydrogen bond. Okay? And this, what are the necessary condition for atom B? What is the necessary condition for B? One is B should have what all conditions? Lone pair of electron, and also it should also be highly electronegative like nitrogen, oxygen, and fluorine. Okay, what are the necessary conditions for A? It should be highly electronegative. And between A and H, what kind of bond should be there? Covalent bond. Okay, so the force of attraction when the hydrogen atom that is covalently bonded to an atom, electronegative atom A, is experiences an attractive force from another electronegative atom having a lone pair of electrons. So when a hydrogen atom that is covalently bonded to when a hydrogen atom which is covalently bonded to an electronegative atom experiences an attractive force from another atom which has a lone pair of electron and which is highly electronegative. And this force of attraction is called as hydrogen bonding. Okay, so I repeat once again, hydrogen, it is bonded to a covalent bond A. This atom A is highly electronegative, so it attracts the electron pair, giving hydrogen a slight positive charge. And another atom, which is highly electronegative and has a lone pair of electrons, comes near this hydrogen. There is an attractive force between the hydrogen and atom B. And this force of attraction is called as hydrogen bond. Okay, and we have already learned in the lesson about electronegativity that fluorine, oxygen, and nitrogen, they are highly electronegative, fluorine being the highest with the value 4, and oxygen is 3.5, nitrogen is 3. There were some atoms whose electronegativity value you had to memorize it, so they were one of them. And in organic chemistry, when you learn, in organic chemistry, you will learn that carbon and chlorine, okay, and they also display what? They also display the hydrogen bonding, okay? Okay, students, suppose this covalent bond is, suppose X, okay? And suppose the bond between this hydrogen and B is Y, okay? So the bond energy of covalent bond, X is covalent bond, right, is greater than the bond energy of hydrogen bond. We already know, we discussed this beginning of the lesson, right? So if the bond energy of covalent bond is greater than that of bond energy of hydrogen bond, what about the bond length? Bond length. Bond length of, if the bond is strong, that means the bond length is shorter, right? So the bond length of covalent bond is less than that of the hydrogen bond. Okay. Now students, moving on further. Keeping this like this. So X and Y I'm just removing. Now, if I have a question where A is bonded to hydrogen with covalent bond and A is highly electronegative and it will pull the electron pairs towards towards itself. The hydrogen has a positive charge. And when any atom B, which has a lone pair of electrons, comes near hydrogen, there will be forces of attraction between the hydrogen and B. And this is the hydrogen bond. And this is the hydrogen bond. We discussed this just a while ago, and this is covalent bond. Yes. Now, so this is X and this is Y. Sorry, this is X and this is Y. Yes. Now, suppose if I give a question, I'm giving you 3 multiple choice. You have to pick one of them. Okay. So bond energy of X is greater than bond energy of Y. Or B option is bond energy of X is equal to bond energy of Y. Okay, so X refers to covalent bond, Y refers to hydrogen bond. C is bond energy of covalent bond is less than that of bond energy of hydrogen bond. Now, we already know that bond energy of covalent bond is greater than that of hydrogen bond. This is true, right? Now, third condition is totally false because covalent bond is always stronger than hydrogen bond. In 99% cases, this is true, but there is a small condition, or there is one special case where the hydrogen bond is as strong as covalent bond. Very, very small condition, or very, very, okay. So, an example where the covalent bond strength is equal to hydrogen bond strength. We have a special case. Example is HF2 minus. Okay. Here, fluorine is bonded to hydrogen. Okay. Fluorine is highly electronegative. It will attain a negative charge. Hydrogen will attain a positive charge. And this will form a hydrogen bond with fluorine. Okay. And this hydrogen bond strength is equal to the strength of what? The covalent bond. Okay, so this is the special case where the hydrogen bond strength is equal to that of the covalent bond. Okay, so this is the special case. So 99% covalent bond is stronger than hydrogen bond. This is true 99%. So this is the special case, the example that I have given. Okay, third option is totally incorrect. Okay, so just a special case here. Now, moving on further, students. Suppose a covalent bond is formed between HF molecules. Okay, so you know fluorine is highly electronegative and it is bonded to hydrogen in a covalent bond, forming covalent bond. Yes, so I'll draw this. Fluorine is bonded to hydrogen. Now, so this fluorine will attain a negative charge, hydrogen will attain a positive charge. So if there is another atom B, let it be fluorine. Okay, fluorine has a lone pair of electron. This hydrogen will attract the fluorine and there is a hydrogen bond formation. So this is the hydrogen bond formation. Right? Now, similarly, so this is for A. Similarly, I have atom B, suppose, which is water. Hydrogen is covalently bonded to oxygen. This oxygen has a lone pair of electron. Okay. I have another hydrogen over here. This oxygen is highly electronegative also. So it will attract the electron pair. Hydrogen develops a positive charge. And there will be a force of attraction between this electronegative oxygen and hydrogen. Right? So this is also hydrogen bond. Hydrogen bond formation in water. Yes. So this is the AHB. So this is AHB, right? So this is AHB. I'm just naming it because we started the lesson in that way. That's it. No problem. If you understand it, it's not a problem. Okay. Now coming to C, ammonia. So what are the necessary conditions? A should be highly electronegative, that is covalently bonded to hydrogen, and B should have a lone pair of electron. It should also be highly electronegative. So in these cases, you will see that nitrogen, oxygen, fluorine are highly electronegative. Now coming to ammonia, nitrogen, this is hydrogen, 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 this is ammonia. So nitrogen, hydrogen, hydrogen, hydrogen. So nitrogen has a lone pair of electron. So there can be a hydrogen bond between hydrogen and this nitrogen. This is hydrogen bonding. So the hydrogen bonds are shown in HF, water, and ammonia. Right? So in this, I have AHB. Right? Now, students, in this case, can you tell me A, B, or C, which has the highest hydrogen bonds? So can you arrange A and A, B, and C, arrange A, B, C in the order of hydrogen bonding, which is having highest, which is having the least. So the order is, I hope you will be able to guess. Fluorine is the highest, highly electronegative compared to nitrogen and fluorine. So definitely hydrogen fluorine will have the highest hydrogen bond or more stronger hydrogen bond compared to oxygen. So next one will be water and next one will be nitrogen. As we already discussed the value of electronegativity over here, you can see here, we wrote the value of electronegativities of nitrogen, oxygen, and fluorine. Okay, I think I wrapped it. So, fluorine, oxygen, and nitrogen, the electronegativity values are in the order 4, 3.5, and 3. So based on this, who is highly electronegative? Fluorine. So HF bonds will be stronger compared to water and ammonia. So what is the reason you will write? Reason is A should be, so that's the reason I have written A in all of them. See, AHB, AHB. So the atom that is covalently bonded to hydrogen should be highly electronegative. Yes. So more electronegative that atom, more stronger is the bond. So A should be more electronegative to form strong hydrogen bond. Okay, and vice versa. This is the reason. So writing a condition over here, strength of hydrogen bond is directly proportional to what? Electronegativity of A. A is what? The atom that is covalently bonded to hydrogen. More the electronegativity of A, more is the strength of what? Strength of the hydrogen bonding. I hope I am clear here. Right? Now, so if they ask you to compare, you have to check if the atom AB should also be electronegative. Yes, but one of the necessary condition is A is highly electronegative. More the electronegativity of A, more is the strength of the bond. Okay. Moving on further. Moving on further, if I have a question where you have to compare the electronegativity OH bonded to O. OH bonded to N. So I will show the hydrogen bond in red. Okay, so hydrogen bond in red. Okay. Now C is NH bonded to N. Then D is NH bonded to O. Okay. So here the AHB, right? AHB, 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 right? We know this. Now, the electronegativity of which is greater, A, B, C, or D? So obviously, here there is no fluorine. Here we check the electronegativity of A. Electronegativity of A, right? The A atoms. So in A atom, the choices are between oxygen and nitrogen. Among oxygen and nitrogen, who has higher electronegativity? Oxygen. So I'm just checking the A atom. I'm not checking the B atom. I'm just checking the A atom, right? So if I check the A atom, A and B, A atom is oxygen in A and B, right? In A and B, we have A atom is oxygen, which is highly electronegative. So I'm ruling out C and D for now. Okay. Now, among A and B, which one has a stronger hydrogen bond? Yes. Over here, the electronegativity order, fluorine is greater than oxygen, is greater than nitrogen. Now, if We know this order. So on the basis of that, we choose A and B. Now in A and B, which one will we choose? A option or B option? Before we determine, I'll just tell you one necessary condition. One necessary condition is that we learned already. Hydrogen bond strength is directly proportional to electronegativity of A, atom A. Okay. Another necessary condition is hydrogen bond strength is inversely proportional to electronegativity of B. So now tell me, which one will you choose, A or B? So the answer is what? Answer is not A, the answer is B. Because if the electronegativity of nitrogen is less, that means it will not pull the electron pair towards itself, right? So hydrogen will be able to pull the electron pair towards itself. So the hydrogen bond formed is very, very strong. So we learned two more conditions. One is for hydrogen bond to be strong, the electronegativity of atom A should be more. What about the electronegativity of B? B should be lesser, inversely proportional. Okay. So students, I gave you four options, A, B, C, and D, and I asked you to choose which one has a higher or stronger hydrogen bonding. So first, we check the electronegativity value of A. More the value of electronegativity, more is the hydrogen bond. So we ruled out C and D because in this case, nitrogen has a lower electronegativity. A atom is nitrogen in C and D. So it has lower electronegativity compared to the A atom in A and B, which is oxygen. Okay, so among A and B, among option A and B, which one will you choose? We choose we choose B because the second condition is that hydrogen bond is inversely proportional to electronegativity value of B atom. Okay, so you have to choose, you have to look at both of them. So what are the two conditions for a strong hydrogen bond? One is the electronegativity atom of, so we have AHB. So electronegativity of A should be more, the electronegativity of B should be, it should also be electronegative, but it should be lesser. Okay. So these two conditions you must remember. Now, the different types of hydrogen bonding, which is very important. One is intermolecular hydrogen bonding, and one is intramolecular hydrogen bonding. So these are the two types of hydrogen bonding. Okay, so let's start with the types. We have to know the type. The first one is intermolecular hydrogen bonding. So just like inter-school competition. So between two different schools or between three different schools, there's a sports competition between 5 different schools. So between different schools, right? Or between two different schools. Okay, so intermolecular means between hydrogen bonds between different molecules. Between different molecules. For example, we just saw many examples that just a while ago. For example, if I say water. Okay, now, so the necessary condition is hydrogen should be covalently bonded to electronegative atom, and B atom should have a lone pair of electrons. So H, O, H, and so on. So here, so this is A, this is H, and this is B. So we can consider like that. Now, this oxygen has a lone pair of electrons, so there can be force of attraction between oxygen and hydrogen. There can be force of attraction between oxygen and hydrogen. These are called as hydrogen bond. Now here, the hydrogen bond is between two different molecules. Even though all molecules are the water molecules, but it's not within the same molecule, right? There are two or more molecules that are present. Similarly, so this bond is happening between two or more molecules. Okay, even though all the molecules are water, but there is a presence of two different molecules. Similarly, I have hydrogen bonded to fluorine, hydrogen bonded to fluorine, hydrogen bonded to fluorine. So over here, there can be hydrogen bonds between fluorine and hydrogen, chlorine and hydrogen. Here also, there are many hydrogen fluoride molecules, right? So here also the bond is happening between different molecules. So this is an example of what intramolecular hydrogen bonding. Now in this, since all are hydrogen fluoride molecule, this is called as homomolecules. Same molecules, but many are there. Here also water. Many water molecules are there, but the species is the same, that's water. So that's why we call it as homomolecules. So intermolecular means, like, you just remember two different schools or two schools, right? Competition between two schools. So same way, bond is formed between two molecules, right? It can be same molecules like this, okay, like water, many water molecules. There can be hydrogen bond between many water molecules. There can be hydrogen bond between many hydrogen fluoride molecules, or there can be hydrogen bonding between two different molecules as well. For example, alcohol. This is alcohol. When you learn organic chemistry, you will learn all these functional groups. Alcohol and water. Water. Okay. So there can be hydrogen bonds between two different type of molecules, and this is called as heteromolecule. Heteromolecule, because two totally different molecules. Okay. Whether it is happening between two different same types of molecule or two totally different kinds of molecule, like heteromolecule. Here, the hydrogen bond is formed between different molecules, and this is called as what? Intermolecular hydrogen bonding. Okay, so it involves the presence of two or more molecules. It can be the same type of molecule or different types, like the heteromolecule. Okay, now, for example, if we talk about boric acid, don't worry about the formulas and all now. I will be giving now the formulas. When you learn the different lessons and all the formulas you will know. Okay. So this is the formula for boric acid, H3BO3. Okay. Now, it has been found that this boric acid exists as a dimer. Okay, they exist as a dimer. What is the reason for the existence of boric acid as a dimer? Now, if I draw boric acid, HO, B, there are three OH. Okay, so there are three OH bonds here. Now, I'm drawing another dimer means two boric acid together. They exist as di means two. So two boric acid existing together. So I draw another boric acid, OH, H, and OH. Okay, and guess what? What can be formed between this oxygen and hydrogen? There can be a formation of hydrogen bond. There can be a hydrogen bond formation, and this is called as dimer. Okay, because of what? Intermolecular hydrogen bonding. So there are two molecules of boric acid. So definitely two molecules are there. So it is intermolecular hydrogen bonding, because of which boric acid exists as a dimer, and it is also called chelation. And you can see that it exists as a ring-like structure. Yes, it is forming a ring-like structure because of intermolecular hydrogen bonding. Yes, and that is why it is existing as a dimer. So this is the first case. Okay. So if they ask you why boric acid exists as a dimer, because of the intermolecular hydrogen bond. Okay. Second is carboxylic acid. Carboxylic acid, the formula is RCOOH. Okay. In grade 12, you have the whole lesson on carboxylic acid. Okay. Now, if I have a carboxylic acid like this, OOH. Okay. And I have another carboxylic acid. I have another carboxylic acid which has double bond like this and OH. What can happen between, what kind of bond can form between this oxygen and hydrogen? There can be what? Presence of hydrogen bonding. So this is AHB, right? So this is AHB, right? So there can be hydrogen bond. Here also, carboxylic acid exists as what? Dimer, because of intermolecular hydrogen bonding. See, you can see there are two molecules of carboxylic acid. Okay, though it's the same molecule, but it is, the hydrogen bond is between two molecules. So it is intermolecular hydrogen bonding. Okay. Now, another case. So these special cases are very important because questions they ask from the special cases. Now, the third one, all these while we were talking about hydrogen bond is fluorine, oxygen, and nitrogen. Now, we are going to discuss a special case due to carbon. Okay, so this is a special case, not very common, but a special case. Now I have chloroform, CHCl3, chloroform. Chloroform, plus I have acetone. It's a ketone. Don't worry about the formula, again I'm saying. Okay, so this is carbon connected or bonded to 3 chlorine atoms, and this is hydrogen. And for acetone, I have C double bond O. This is CH3, and this is CH3. Okay. Now over here, the 3 chlorine atoms are highly electronegative, so it will pull all the electron pairs towards itself. So carbon is left with is less of electrons because all its electrons are uh, pulled by the chlorine. So what will carbon do? Carbon will become highly electronegative and it will pull the electrons of hydrogen. Carbon has become highly deficient of electrons. So I was looking for the word deficient. Carbon becomes highly electronegative because it is deficient of electron. So it will pull the electrons of this hydrogen. Okay, and as a result, hydrogen develops a partial positive charge, and this oxygen has a lone pair of electrons. So definitely what can happen? There can be hydrogen bond. Okay, so this is a special case where the carbon has become highly electronegative, and as a result, there is hydrogen bond between hydrogen and oxygen. I hope it is clear, right? So this, please remember this. Sometimes they give like 4 options. Which of them don't form hydrogen bond? So quickly students try to take this option, but you have to remember this as a special case. I hope I'm clear. Okay. So students, moving on further. Okay. Now, if I ask you a question, which is more soluble in water? Which is more soluble in water? Is it Na plus or ammonium? Okay, so this case of sodium ion we already discussed when we were discussing the van der Waals force. So this is the sodium ion, and suppose it is surrounded by the water dipoles. So these are all the water dipole. So if it is a dipole, there's a negative charge here. They will align in such a way that the negative charge comes near the positive charge. Okay. So this is negative, this is positive, this is negative, and this is positive. Okay. Here there's an ion, and here there's an ion, and here there's a dipole. And what is this interaction? This is ion dipole interaction. And this is a kind of van der Waals force. So sodium ion is soluble in water, but the interaction is not very strong. Why? Because this is a kind of van der Waals interaction. Okay. So I have van der Waals interaction. Coming to the NH4, right? So there's a coordinate bond for ammonium. Okay. And this is surrounded by water molecules. So I have water. Water I'll put with blue color. I'll use blue color for water. So oxygen. This is hydrogen. Here again I have oxygen. hydrogen, hydrogen. These are the water molecules, right? So ammonium ion is surrounded by water molecules, and there can be hydrogen bond formation between the oxygen and the hydrogen, right? And this hydrogen bond formed is very, very strong, right? So both Na plus and ammonium both are soluble in water, but ammonium ion, because it is forming hydrogen bonds with water, they form more stronger bonds with water. Okay, and it is more, that is the reason they are more soluble. So we can write as a note that any substance, anything that is forming hydrogen bonds with water, more stronger hydrogen bond is with water, is more soluble in water. So if strong, we can write as a note, if strong hydrogen bonds are formed, results in high solubility. Okay. So this is also another important condition. Now coming to another question, alcohol. This is alcohol, amine, NHRNH2. This is amine, okay? Now, my question is, alcohol or amine, which is more soluble in water? Which is more soluble in water? Okay, so we take the case of alcohol, ROH. So I have water here, OH, H. So I have, this is AHB, right? So there's a hydrogen bond formation over here. Okay. Similarly, in amine, I have R, N, H, H. This is oxygen, hydrogen, hydrogen. So this is AHB. So there can be a hydrogen bond formation here also. Now, one of the necessary conditions that we learned is for strong hydrogen bond, electronegativity of A should be more. So electronegativity of A, if it is more, hydrogen bond more stronger. It also depends upon the electronegativity of B. Smaller the electronegativity of B, more stronger is the hydrogen bond. But in this case, in both the cases, B atom is the same. So we need to check the electronegativity of A. Oxygen or nitrogen? Who has higher electronegativity? Oxygen. So definitely alcohol has more stronger hydrogen bonds than amine, because what is the reason? Oxygen is highly electronegative compared to nitrogen. And electronegativity of A, if it is more, hydrogen bond is stronger. In this case, A is either oxygen or nitrogen. In this case, oxygen is highly. Okay. Now, moving on further. Again, a question which has more boiling point. Okay. HF, HCl, HBr, HI. Okay. We know that boiling point is directly proportional to molar mass. So that means iodine has a higher molar mass. So HI will have a higher boiling point than HBr, then HCl, and then HF. But here there is a small discrepancy that HF forms strong hydrogen bond. That's why it has the highest boiling point compared to the others. So HF has the highest boiling point because of what? Hydrogen bonding. So it has higher boiling point, then the rest of the order is the same. HF is greater than HI is greater than HBr, is greater than HCl. For rest of them, we check the molar mass. Okay, but for HF, we cannot check the molar mass because they form strong hydrogen bonding. Okay. Now, in the same way, if a question comes, how many hydrogen bonds are formed by one molecule of water? So this is one molecule of water. Okay. And in this is another molecule of water. This is another molecule of water. Another molecule of water. Another molecule of water. Okay. Now, in this hydrogen can form a hydrogen bond with oxygen, right? Similarly, they can also form, this hydrogen can also form a hydrogen bond here. This oxygen can form co-hydrogen bond with this hydrogen. Similarly, this hydrogen can form a hydrogen bond with oxygen. So, if we check one molecule, so if I'm checking one molecule, this is one molecule. Okay. This is one bond it is forming, second bond, third hydrogen bond. I am talking about hydrogen bond only, fourth hydrogen bond. So how many hydrogen bond is formed? 4 hydrogen bond by one molecule. Okay, so I did the circling wrong. So I have to circle in this way. This is one molecule. Okay, and one hydrogen bond, second hydrogen bond, third hydrogen bond, and the fourth hydrogen. So each molecule is surrounded by 4 water molecule, and it forms 4 hydrogen bond. I hope I'm clear till now. Okay. Now, moving on further. The next type of bonding is intramolecular hydrogen bonding. That means intra, within the molecule. So hydrogen bond is formed within the molecule. For example, if I say this is phenol, okay, and if we take this OH, the position of this carbon over here, this is the ortho position, this is the meta position, and this is the para position. And similarly, on the left-hand side, this is the ortho position. This is the meta position. Right. Now, if I take ortho nitrophenol. This is ortho nitrophenol. Yes, ortho nitrophenol. There can be a hydrogen bond formation between, this is O and this is H. There can be a hydrogen bond formation between this H and this O, and it is happening within the molecule. There is no requirement for another molecule, and this is intramolecular hydrogen bonding. So it is happening within the molecule. Okay, so this is ortho. This is the case of orthonitrophenol. Similarly, I take another example of, suppose, OH and N double bond O. This is O. This is in which position? Nitro group is in which position? Para nitrophenol. Suppose I bring about another para nitrophenol. Okay, so I bring about another para nitrophenol. N double bond O, single bond O. This is OH. Here there are two molecules of para nitrophenol. So there can be a bond formed between this oxygen and hydrogen. Now there are two different para nitrophenol. Because it is happening between two molecules, this is intermolecular hydrogen bonding. So para nitrophenol shows intermolecular hydrogen bonding, whereas the orthonitrophenol displays intramolecular hydrogen bonding. So two different types of hydrogen bonding. Right. Now, if a question is asked, ortho or para nitrophenol? Orthonitrophenol or para nitrophenol? Who has higher melting point? Who has a higher melting point? Obviously, it is the para nitrophenol, because the para nitrophenol has intermolecular hydrogen bonding. And you have to break these bonds. These two molecules have to move further away for this bonds to break. So that is why para nitrophenol has a higher boiling point and melting point. Okay. In case of the orthonitrophenol, we didn't select orthonitrophenol because if there are a lot of orthonitrophenol molecules, there will be no intramolecular hydrogen bond. In fact, there will be van der Waals force. This intramolecular hydrogen bond is for single molecules. Okay, if there are many orthonitrophenol, there will be just small force of attraction which will be van der Waals force. So the energy required is very, very less. So that's the reason if we compare ortho and para will have a higher melting point or boiling point than the ortho one. Okay. So if the same question is asked in another way, which is more volatile? If the same question is asked in another way, which is more volatile? More volatile, that means who evaporates fast. Whichever has a low boiling point. So ortho has lower boiling point. So definitely orthonitrophenol is highly volatile. Yes. Similarly, if a question is asked, why can they be separated, orthonitrophenol and paranitrophenol be separated by fractional distillation? Yes, because fractional distillation is a method that involves a condition that the two substances should have different boiling points. So definitely we can separate them by fractional distillation. Okay, so these are few applications of hydrogen bonding. Okay, so students, we studied what is hydrogen bonding. We studied many examples, some exceptional questions, and the different kinds of hydrogen bonding. And we also saw some application question, why some substances are more soluble than the other. Okay, so students, that's all for today. Have a great